All right, let's get started. Now, in today's class, we're going to start with regression. And under regression, we're going to consider linear regression, and then we also consider logistic regression. Okay, we consider linear regression, then we consider logistic regression. But in this particular video, in this particular class, we are going to first take a look at a linear regression. Then in subsequent videos we will proceed to logistic regression. All right, so in this particular video we're going to start with linear regression, then we proceed to logistic regression respectively. All right, so let's proceed to linear regression. Now before we dive deep into linear regression, let's see what regression itself is about, and what is the difference between regression and then correlation, right? So mostly what people confuse themselves with is the difference between regression and then correlation, right? So let's start by first getting ourselves familiar with what regression is and what correlation is, right? So that things will become clear right from the beginning. Okay, things will become clear right from the beginning. So all right, so let me give you just let me go to the board and then give you just a simple difference between logistic and then correlation, right? So just to make things clear with you, just let me make things simple over here for you. All right, so when we talk about the correlation, right? When we talk about correlation, right? When we talk about correlation, what we mean is that we want to measure the relationship, right? We want to measure the relationship, right? Let me even bring it here. Right. When we talk about correlation, what we mean is that we want to measure the relationship, right? We want to measure the relationship. Okay, we want to measure the relationship, right? Or relationship or association, right? You can also consider it that way. Right, relationship or association between two variables. Right, so when we talk about correlation, that's what we actually try to do, right? Try to measure the relationship, or the relationship or the association which is existing among two variables. Now, what mostly happens is that if you take say a person's weight, right? If we take let's say we have a person known as, say, let me just take a name, like a person known as Sanjay, right? So if we take, say, Sanjay's weight, right, if we take the weight of this person, right, if we take the weight of this person, and then maybe if you consider the weight of the person and the food the person eats, right? Maybe the eating habit of the person, right? So now, can we measure a relationship or association between these two variables, right? That is describing this person, Sanjay, right? These two variables that is describing this person, Sanjay, right? Can we find a relationship, right? Can we say that the weight of the person is depending on the food or the person is eating, right? Can we find that kind of relationship or association? Can we do something like that? Okay, now if we are trying to answer such questions, then we are talking about correlation here. Okay, then we are talking about correlation here. So what correlation does is that it will give you a number, maybe 0. Maybe 0.8 or something like that, or maybe 0.2, right? Where a higher correlation, or Pearson correlation, actually, right? So mostly what we use is the Pearson correlation, right? I'm sure those who have gone through the statistics class are aware of Pearson correlation, right? So what mostly we would do is to use this Pearson correlation to give these probabilities, right? So if you take, say, 0.8, right, and then it means that these two variables are highly correlated, right? If it is closer to 1, right, so it's always going to be between 0 and then 1, right? So if it's closer to 1, right, whatever value that you're getting, right, mostly the Pearson correlation is represented as r square. So if you find the value of this r square and it's closer to 1, right, if the value is closer to 1, then we can say that these two variables are highly correlated, right? However, if you find the value and it's closer to 0, right, if the value you found is closer to 0, then we can say that they have a low correlation, right? But if it's closer to 1, then you can say that they have a high correlation. So that's what correlation will actually help us to do, to see, to give us in a quantified manner like this, right? I mean, they're giving us this Pearson correlation, right, in the form of, you can say a form of probability, right, a form of probability. So you can see that the higher the probability, the higher the correlation that is existing among these two variables, right? But if it is low, right, if the Pearson correlation value is low, then you can see that these two values are not highly correlated, right? And it's not zero, just positive. It could be plus or minus, right? So it could be from -1 to +1. Okay, so in between that, right? So it could be negative, it could be positive, right? So these items could be negatively related or correlated, right? So it could be negative, say 0.7, right? Or maybe negative 0.3, right? Or maybe positive 0.4, something like that. Okay, so that's what correlation will help us to do, to give us, in this kind of correlated figures. All right, in this kind of correlated figures. Now, this is correlation. What will regression help us to do, right? So if we take regression, right? If we take regression, what regression will help us to do, right? Let me push this a little bit up so that you can get to see it very well. Okay, now what regression will help us to do that? If you find this correlation, right? If you find this correlation, can we base on this correlation and then make some feature predictions? Can we do that, right? By drawing a regression line, can we predict in future, right? Can we make some feature predictions, right? So what regression will help us to do is that it will help us to draw a regression line where we can use this regression line, right, to make feature predictions. So if we have a new data point, right, if we have, maybe you used your existing data point to draw this regression line. Now if you have a new data point coming in, right, can we make a prediction? Can we trace to the line and then make predictions, right? Maybe this one will be maybe some food items, right? Maybe some food items, or maybe the food, right? Let's just take the example that we used earlier on, right? For Sanjay, maybe here will be food, here will be the weight, right? Here will be the weight. So later on, if we see the kind of food that Sanjay is eating, can we predict the weight that he will be having in the next 6 months? Can we do that? Okay, that's what regression will help us to actually do, right? So correlation will help us to find the relationship between weight and food, whilst regression will help us to make feature predictions. So if, say, later on, if we see Sanjay eating, say, chicken fried rice, can we predict the weight that he will be having in the next 7 months? Can we predict that weight, right? So that's what regression will help us to do, right? So you get to draw a regression line, right? So this one here is a regression line, right? So you get to draw a regression line that is going to actually help you make those feature predictions. Okay, we're going to see this as we progress to our lab session. We're going to see how this is being done. So I just wanted to have a clarification here, what correlation will help us to actually do, right? What correlation will help us to actually measure, and then what regression will help us to do in the future. Okay, so that's basically the difference between correlation and then regression here. All right, now having said that, let's start with our linear regression over here, right? Let's start with our linear regression over here. So we're going to talk about linear regression, right? We're going to talk about linear regression.